Good evening and welcome to NASA at Your Table. I'm Dorothy Stoltz with the Carroll County Public Library. I have the honor of being the board president for the Maryland STEM Festival, and this is a Maryland STEM Festival event. The festival is a month-long celebration of STEM, science, technology, engineering, and mathematics, and it will run through November 14th. Thank you to our sponsors, NASA and the Maryland STEM Festival, and thanks to our co-hosts, Carroll County Public Library and the Maryland State Library, along with 5 other county libraries, including Cecil, Howard, Montgomery, Talbot, and Wicomico Public Libraries. Now, I'd like to introduce Carrie Sanders from the Maryland State Library. Carrie is the Youth Service Coordinator for the Maryland State Library, where she provides consultation and training to youth services coordinators for all Maryland public libraries in the areas of early literacy skills, media mentorship, STEM and STEAM programming, teen services, family engagement, and other initiatives surrounding youth services. So let's please welcome Carrie Sanders.
Thank you, Dorothy. It is a pleasure to be here with all of you this evening. The Maryland State Library is just so pleased to have been able to be working with Phil and the Maryland STEM Festival these last several years. As Dorothy mentioned, Maryland Public Libraries provide a wide array of programming, from early literacy all the way up through teen services, but we have a special spot in our hearts for STEM. It's so fun to bring the exploration, the inquiry that comes with STEM programming really to all ages. Little ones can be involved all the way up through teens. And what we really love is that families can be engaged together in these programs. So lots of STEM happening in the public libraries around Maryland really all year round, but especially now. So please check out what's happening in your public library in your community for a wide array of STEM activities. So it is a pleasure to welcome Phil. Phil Rogovsky is the founder and executive director of the Maryland STEM Festival. He is a lifelong fan of STEM, starting with the Apollo program. One of his STEM highlights was meeting astronaut Ricky Arnold, a fellow graduate of Bowie High School. He is very proud that the Maryland STEM Festival has become a connective tissue for the Maryland STEM community. I love that. He grew up in Bowie and is a graduate of the University of Maryland. He lives in Columbia with his wife, and he is the proud father of 2 children, 3 cats, and a turtle. Phil is a retired federal worker, and when he is not focusing on STEM and his family, he is an active member of his synagogue, enjoys tennis, yoga, and listening to music. So it is just a pleasure to be here with you, Phil. Thank you for all you do to bring STEM to the families in Maryland.
Thank you, Carrie. And it's an honor to be here, and it's an honor to run the Maryland STEM Festival and partner with the libraries. As you have so eloquently mentioned, the libraries are one of the biggest promoters of STEM throughout Maryland. I'm frequently asked, where can I go to take my kids to learn more about STEM or to do more STEM things? And I'm always directing them to the Maryland libraries. You've been the biggest partner of the festivals, and I love the relationship we have and look forward to keep growing and growing.
Absolutely.
And I'm very happy to be introducing our presenter tonight. The festival has a great relationship with NASA, which I'm very proud of since, as was mentioned, I've been a fan of NASA since as far back as I can remember. So our presenter tonight is Dorian Janney. She has a passion for sharing the wonders of NASA's science and exploration with students and people of all ages. And that began with her career over 30 years ago when she started as an elementary school teacher in Montgomery County. She also taught secondary school in Montgomery County, and in 2013 left the county system to join the NASA family. She has been a Einstein Fellow finalist, and she is National Board certified in science education. And the best way to describe what she does now is to list what she lists in her signature on her emails. She is a senior NASA Earth Science educator and communications specialist. She is the Global Precipitation Measurement Coordinator. She is the Globe Mission Mosquito Campaign Lead for Globe, K through 12, and Lifelong Leaders, and the Globe Education Working Group. And Globe is the program for global learning and observation to benefit environmental program. And if you want to learn more about her, you can also listen to a podcast I did with her on our Fun with Maryland STEM Festival podcast, which is available anywhere you can find podcasts. So I will now turn the program over to Dorian and sit back and enjoy the program.
Wow. Thank you both. Phil, you also mentioned it being an honor, and it truly is. It's just such an honor to be able to, share things that you're passionate about and things that you learn about. As Phil mentioned, I'm Maryland born, Maryland raised. I actually went away for a few years and had my first child in Houston, Texas, and then came back to Maryland, feeling kind of like Dorothy in The Wizard of Oz, where she, clacked her shoes together and said, "There's no place like home." And I know there's a lot of absolutely amazing places in the world because I have the good fortune of doing a lot of traveling, both within the United States and outside of the United States. But at the end of the day, this is an absolutely amazing place to live. I love Maryland. And I just also have found I love learning, and I never tire of the opportunities and the advantages that we have in the DC metropolitan area, being able to learn. One thing I didn't mention in any of the things that I sent to Phil and to the Maryland STEM Fest is that I'm also a docent. I'm a volunteer at the Smithsonian Museum of Natural History. And I just did that because I love science so much, and I've always loved going to the Natural History Museum in DC. And when I found out that they were going to have an exhibit that focused on global pandemics, and this was before COVID-19, I was so intrigued and so engaged in wanting to learn more that I became a volunteer there. So if you ever get a chance, you probably didn't realize that the Smithsonian Museum of Natural History has a wonderful exhibit on the second floor that focuses on global pandemics. But tonight, I am here to talk to you about NASA at your table. This is the first time I'm giving this particular presentation. I worked with the campaign for NASA, which looked at how can we tell the story of the ways in which NASA satellite data are being used to help us better understand agriculture and drink and really literally bring food to your table. So my presentation tonight, you're my guinea pigs. You're the first ones who are getting it. And it's going to focus on some of the resources that were developed by a wide variety of specialists at NASA, and helping to tell the story that not only does NASA, study other planets and the universe and beyond, and the moon and the sun, but we also study this amazing planet that is near and dear to all of us, our home planet, planet Earth. And there are a lot of really good reasons why we are studying our home planet. So I love talking about the ways in which NASA satellite data are used for real-world applications, and particularly in this case, when we're talking about food and drink, because of course, everyone needs to eat. Not only do we need to eat for our very survival, but food is such an important part of our culture. It is, a way that we express ourselves, a way that we understand where we're from and how we're related, to others on this earth. Crops and animal products, whether we get them from the ocean or on the land, from farms, from our own, relative close by Maryland area, or whether we're getting them from other countries, they all draw on sunlight and water and soil to be able to grow. So what I want to talk to you about this evening is I want to share with you some information about how and why NASA satellite data are being used to help us sustain our food and our drink, and to actually even bring about improvements to the food and the drink that we all enjoy every single day. And I also want to be able to introduce some of you to some potential STEM, science, technology, engineering, mathematics, career opportunities that you may not know that exist. So those are the things that I want to do with my presentation this evening. I also would love to have your engagement if you feel comfortable doing this. This is a Padlet, which some wonderful Montgomery County Public School educators who are teaching virtually taught me how to use. And basically, if you shine your phone on this with your camera, it will open this up, or if you put in the link for this Padlet. But this is a Padlet that I thought would be really interesting to get your understandings and your background knowledge as to how NASA Earth science information might impact and influence the food and drink that you have. So there's 3 questions in this Padlet. And remember, no answer is a wrong answer. And you can even answer a question with a question. One of them is, why do we need to measure precipitation? Because the satellite that you see behind me and the satellite that I support at NASA is the Global Precipitation Measurement mission. I'm going to tell you more about that mission and how it works, and show you our latest data. And I want you to be thinking about, why might we want to measure global precipitation to help us better understand things like agriculture? Then I'd like you to also think about, what is the impact of climate change on agriculture? Because I'm going to dive into that a little bit. And how do NASA satellites bring food and drink to our table? So I'd love to have any of your input on any of these questions or all of these questions on the Padlet. And later in this program, we will look at what you responded with and share some of that information with from the Padlet. And if you're reviewing the archive of this, go ahead and add your information. I'm going to be checking this Padlet on a regular basis, and I hope to be giving this presentation again. I'll learn some things from giving it tonight, how to hopefully make improvements on it, and then we'll give it a couple more times. So the Global Precipitation Measurement mission, the one that I work for as the Education and Outreach Specialist, this is a absolutely amazing satellite mission that is a joint mission with Japan. It was launched in 2014, and it is a follow-up to the TRIM, which stands for the Tropical Rainfall Measurement Mission, which is also a joint mission with Japan and was launched in 1997. Now, the really neat thing with science and technology is, with science, we kind of have this feel that if we had this technology, we could use the data that we collect to better understand a variety of different topics. And so then we work closely with engineers for them to be able to develop the technology that we can use to gather the data that we want. So what we're seeing in this animation is we're seeing that the Tropical Rainfall Measurement Mission, which was the one that launched in 1997, it was only able to measure precipitation that was at the equator and kind of give us that data. But then, because we learned so much from that satellite mission, when we launched the Global Precipitation Measurement Mission in 2014, this time we were able to take advantage of other satellites that were already up in space, some of which are from the United States and some of which are from other countries. We were able to take advantage of the data they were collecting and have them share that data through our core observatory to now be able to look at how much rain is falling from the clouds all over the earth. And we actually have been able to fine tune our data so that every 30 minutes we get an updated picture of exactly how much precipitation is falling pretty much everywhere in the world. What you're looking at now is the last 7 days of precipitation as it fell to earth from the clouds. If you look at the lower right-hand corner, you're going to see our keys. So our greens to reds are telling us where we're seeing rain, liquid precipitation, and our blues to purples are showing us our frozen precipitation. Take a look at how precipitation moves because of global wind patterns. So we see in the northern and the southern hemisphere, we're seeing that the precipitation is moving from the west to the east, and then we're seeing how it's kind of moving in a conveyor belt fashion at the equator back from the east to the west. So really fascinating to see as we're looking at this precipitation data, where it's falling, and we even are able to measure how much is falling to the millimeter level. And as you might imagine, this data is used in a wide variety of different ways. So it helps us to better understand animal ecology, how animals move, and biodiversity, because of course, everything needs fresh water to survive. And the main source of our fresh water, as I drink my fresh water here, is from precipitation. Even though almost 2/3 of our planet is water, 97% of that water is in oceans, and it's salt water. And we need fresh water to survive, as do most of the animal species and even plant species that we interact with. So knowing where and how much precipitation we have is essential for our understanding animals and biodiversity, for understanding agriculture and how much water is available to be used for agriculture, which we're going to focus on this evening, for understanding energy, things like not only hydro power plants, where we're talking about the fresh water that's flowing in rivers, but also when we're talking about our electric energy and nuclear power. Those power plants need to be cooled off. And the way we cool those power plants off is with freshwater resources. We can't use salt water because the salt could get stuck or would get stuck in the machinery. So therefore, we use actually an incredible amount of our freshwater resources in developed countries for power production. Disasters, of course, as many of us have followed, tropical cyclones, floods, drought, precipitation data is important for that. Health, things like disease, vector-borne, water-related disease, cholera, just a lot of ways in which people's health, and of course being able to have access to freshwater resources so they can wash their hands, is highly contingent upon where rain is falling and other forms of precipitation. And then, of course, weather, which is one of the things people automatically think of. Oh, when we're talking about precipitation, we're talking about the weather. And that's true, but it's fascinating to see the other ways in which how much precipitation falls and where it falls is essential to our well-being. I told you that I'd also tell you a little bit about some STEM careers and some ways in which data from the Global Precipitation Measurement mission and other NASA satellite missions are being used to help us all over the world. So I have done some deep dives into some absolutely incredible human beings and the places where they work, and have created a wide variety of different resources that you can access that will tell you who's using GPM data. I met with a really neat woman named Sarah Davidson, who is a data analyst for MoveBank, which is an organization that takes a lot of freely available data, and all NASA data is freely available, and uses it to create a platform that people who study animal movement can use to help them better understand what environmental factors, such as how much precipitation, temperatures, and other things that we can measure with satellite technology and with ground-based instruments. How does that help us better understand animal movement? Also, I met with a woman named Liz Sacochia, who works as a research analyst with the World Resources Institute. You can learn all about the work that she's doing. And a big emphasis of her work is helping us to better understand how we can bring about peace through understanding where there's conflict and where there are issues related to having access to freshwater resources. So that's a really neat story as well. Faisal Hussein has a lot to do with what we're talking about tonight, and that is, talking about, he is a professor of civil and environmental engineering, and he found a way to help farmers in water insecure countries to be able to just get a text message telling them whether they can just rely on precipitation falling to water their wheat crops, or whether they need to take water from the very, very valuable freshwater resources which are in the rivers that are near them to irrigate their crops. So that's just an example of some of the people I have talked to and worked with over the last year that are showing the ways in which they take this freely available precipitation data and use it to help make the world a better place. So now we're going to dive into NASA at your table and looking more closely at how it helps us ensure that we have food and drink, and the ways in which you will probably be surprised to learn that satellite technology is helping to learn a lot of different things about the food and drink we have available to us. I did pull together some of the case studies, the information from people who use GPM, Global Precipitation Measurement mission data, for the 4 things we were looking at with our NASA campaign this summer when we focused specifically on NASA at your table. And I developed what are called some story maps, some resource packets. One of them looks at monitoring crops with GPM data. Another looks at how we can use GPM data to help monitor drought. Another one looks at how GPM data is helping to improve global food security. So all of those you can take a look at if you feel like learning more by going to the story maps that are all at that link. So now I'm going to stop because I've thrown a lot of information at you and see if there's a couple of questions that I might answer before I move ahead and look more specifically at how a wide variety of NASA data are being used.
Okay, so we have time for questions. Are there any questions coming in, Carrie or Phil?
I see one here. Dorian, can you describe some of the advancements in technology from 1997, when this partnership began with Japan, to 2014, and then even to today for this project? It's just kind of amazing to think about what's happened since the onset of that project with Japan.
No, it really is. And for me, for someone who teaches people about science, technology, engineering, mathematics, it's like a perfect example of the ways in which it can be used. So in 1997, using science and engineering, so the scientists said, hey, we know that we could get some data that would be helpful to us using radar and using microwave data. And we could use that data, and they worked with the engineers, to better understand what they could do with that data. But if we were to get that data, we could actually infer, using remote sensing, we would be able to measure how much precipitation is falling through clouds. And we could also look using the microwave. So let me back up a second. When we're talking about the radar technology, the radar instrument, it just sends down a signal that bounces off the clouds and measures how much radio waves are being emitted or absorbed by clouds. And believe it or not, looking at that data, that can tell you, and did in 1997, how much precipitation is falling through the clouds, kind of like a CAT scan. So if you have a CAT scan, you go in and they use radio waves, and they look into your body. They can tell your soft tissues, your liver, your lungs, kind of get a feel for what's inside there. They get kind of a three-dimensional picture. On the other hand, the microwave data is giving us information kind of like X-rays, where they're looking at your bones. So in this case, instead of looking at the bones of a cloud, we're looking at what's inside, what type of precipitation. So back in 1997, our radar instrument would tell us only about liquid precipitation, so rain, okay? So we could see inside a cloud how much rain was falling in any part of that cloud. And believe it or not, that information was essential in being able to figure out when a tropical storm was actually becoming a hurricane, because we started to notice where there were these areas of a lot of precipitation going up in what we call a hot tower, even though it's not really hot. That told us that that tropical storm was getting more energy and it was going to become a hurricane. So that helped people be able to take those kind of crazy spaghetti models that show, these are all the places where that hurricane may end up hitting. And we were able to really make those models a lot better, a lot tighter fit. So instead of maybe it taking 5 days or 6 days for people to know how much time they had to evacuate from a certain area, we were able to give much more specificity to where a tropical cyclone was going to turn into a hurricane or a tropical disturbance, and how strong it was going to be. So that's one thing that we could do. And then between 1997 and 2014, in 1997, it was just one satellite. So every 3 days, it could give us new information, but not every 30 minutes, because it was one satellite by itself that was doing the work. So as the scientists and engineers watched this between 1997 and when they launched GPM, they realized that there were a lot of other satellites that were in orbit that weren't measuring precipitation, but they happened to have a microwave imager on board. So the engineers worked with the engineers from those different satellite missions and came to an agreement that they would set their microwave imagers to collect data at the frequency that we needed it at, and then we could run all that using supercomputers through our core processor. And so now, every 30 minutes, we're able to measure not just liquid precipitation, but also frozen precipitation, and we get it from all over the world. So pretty amazing over such a short period of time, really. When you look at 97 to 2014, that's a pretty short period of time that we were able to go from just getting it around the equator to getting it pretty much all over the world, and going from every 3 days, just liquid precipitation, to getting it all over the world every 30 minutes, and then getting frozen precipitation as well. So what lies ahead? Well, NASA is very focused on the Earth System Observatory, which is going to be a series of different Earth observing satellites, including some instrumentation that will be on board the International Space Station. And these are going to be focusing on Earth and helping us better understand climate change and Earth systems so that we will be able to respond sustainably and have a better feel for what is changing in our Earth systems. I see, Phil, I think you need to unmute. You bet.
I'm sorry. I'm sorry about that. It's always a little difficult. Don't want to interrupt you. So the question is, how do they decide the jobs of new satellites and when to launch them?
It's like an onion. There's a lot of layers there. The big thing is what's called the decadal survey. So every 10 years, lots of scientists and politicians, decision makers, lots of people get together and talk about, we only have so many resources, we only have so many people who can work on this. What are the things that are most important for us as a scientific, society to focus on? So that's known as the decadal survey. Based on that decadal survey, that then helps to frame what are the satellite missions that are doable. So kind of like those of you who are students, when you're coming up with a scientific investigation, you need to have a testable question. Like I might want to know what kind of lava is coming out of a cinder cone volcano, but I can't actually test that, with the instruments and resources I have. So I need to come up with what is an actual question that I could answer based on the technology I have. And so, of course, with NASA, we have an amazing array of resources available to us. And the Earth belongs to all of us all around the world. Something I love so much about working with NASA and with Earth applications is I work with scientists and teachers and students from all around the world because it's our home planet. And so we don't really have political markers when we're talking about how to work with our home planet as scientists and engineers. We're all sharing the data that we have, or most of us are, and working together as different entities to figure out, given these assets, these abilities, what do we need to know that's going to help the most of us, and what do we need to do in order to learn that? So that's what I was saying is kind of a bit of an onion in that way. And then, of course, we need to have funding. So we have to have people that go before Congress on a regular basis and ask for funding. And then we need to have citizens like all of you who learn that NASA doesn't just send astronauts to the moon and Mars, but we also work hard to protect our own home planet. And so does the European Space Agency and the Japanese Space Agency and so on and so forth. And, as we learn more, we can decide what matters to us. And then we can let the politicians whom we work with and the people whom we vote for know that these are things that are important to me. And all of that comes about by being informed, by learning things and knowing where to look for that information.
Great. Thank you very much.
And maybe I should go ahead now and then take more questions as we go on. All right, good. I love having these questions come in. So I want to just start to now look at not just talking about the Global Precipitation Measurement mission, but other NASA satellite missions as well, and how it ties into food and drink. When you think about the fact that more than 800 million people around the Earth suffer from chronic hunger, and that by 2050, our population, our global population, is expected to, expand. So we need to not just do what we're doing now, but we need to be innovative, and we need to look ahead to the future and get a feel for how are we going to feed people all over the Earth. So I'm going to be telling you this story of how NASA does that. So we're going to start off by looking at freshwater resources.
We live on a water planet. From millions of miles away, Earth shines.
Oh, Dorian, I think we lost your audio there.
All right, let me turn it back
Only
on.
about 3% of water is fresh.
Thank you.
The stuff we drink and use to feed our crops. And it's constantly moving. Through the atmosphere, soil, aquifers deep underground, and even living things. That's where NASA satellites come in. Taking a global look at freshwater provides important information about droughts, floods, and water quality around the globe. The more we know about water and its availability, the better decisions we can make about how to manage it, from identifying food insecurity before aquifers run dry, to pinpointing when and where rivers will flood. Tracking water from space gives us an advantage in using it. For example, looking deep underground, the Gravity Recovery and Climate Experiment, or GRACE mission, measured water stored in aquifers. When human activity and drought drain aquifers, they can be replenished by sufficient precipitation, but they aren't always. GRACE watched how water moved in and out of aquifers from 2002 to 2016. Closer to our feet, water in the soil changes quickly in response to precipitation. We can see soil get wetter in response to rainfall, and about a month later, watch as vegetation blooms where the soil is sufficiently moist. We can track all of these steps with satellites, which help us predict where food insecurity may crop up before it becomes a problem. Satellites help us track rivers and lakes, too. Reservoirs can become contaminated by blooms of algae, which grow in response to fertilizer running off from farms and cities. In the upper Midwestern US, there are hundreds of lakes, so it can be difficult to track them all individually. A view from space helps us keep an eye on lakes with blooming algae. Rivers are an important source of water for communities around the globe. And often, these rivers originate as snow high in the mountains. Snowpack, or the amount of snow that falls and accumulates on the ground, feeds rivers on a seasonal basis. Earlier snowmelt can affect how and where water is available for irrigation. And as the climate continues to warm, snowpack is disappearing at lower altitudes, and what does exist is melting faster. Our planet is constantly in motion, with freshwater shifting around the globe. Those changes are happening faster in a warming world, with precipitation falling in different places and rivers flowing new speeds. NASA's view of where freshwater is and how it moves is even more important than ever. From deep below the ground up into the atmosphere, we're helping people manage their water better.
Good. I hope that was helpful. It's sounds like my husband is burning the house down. I am sorry. Of course, it's been quiet here all day. And now that I'm giving a presentation, I'm sure many of us are used to this now. For some reason, my neighbor is running his lawnmower. I do not know why. And my husband is burning the house down. So I apologize profusely, but we now know during this pandemic time that these are things we just have to kind of get used to. So I hope that gave you a bit of a flavor for, a bunch of different satellites that we have with NASA, and how, not only are we measuring precipitation as it falls to the ground, but we also can use this remote sensing, this satellite technology, to measure water that is underground. So we're able to use a variety of satellite data, as well as using the data that we're getting, from farmers and from, Earth observations that we're making. So we want to use a combination of satellite data, which is very helpful because let's say we're talking about measuring precipitation. I have a rain gauge in my front yard. I go out and I check it every day because I'm a geek. I love to do that. I love when it rains. I think like, oh, did we get an inch of rain or did we get a half inch? And I can go out and look at my little rain gauge and measure it. But 73% of Earth's surface is covered by oceans. And then there's lakes and high mountains. And we can't have rain gauges everywhere. So, and radar doesn't even, extend very far outside developing countries or developed countries. So the long and short of it is we really need this eye in the sky, this satellite technology to help us, be able to really see that bigger picture, that global picture. So not only do we have just the normal things that we have to think about, people to take care of and where existing water resources are, but we also know that climate change is happening. And not only is it impacting us when we're talking about increasing temperatures, but of course, as you would imagine, it's impacting agriculture. It's impacting food security as there's increasing temperatures. We also are noting that we have more extremes in how much precipitation is falling. And a large reason for that is because warmer air can hold more moisture. And when you think about the fact that ice caps and glaciers are melting in many places, then that means that there's more potential fresh water that can be in our water cycle. So for a variety of reasons, we're noting that there are changes that are happening because of climate change, and some of those are impacting our food and drink and are even expected to impact our food and drink even more. Now, I'm going to be putting on a bit of a longer video, and before I do, I just wanted to invite you one more time to go ahead and add your input, and we're going to take a look at that in a little bit here, as to NASA at your table, and put your information in the Padlet. And so I'm going to put on now kind of a fun video. This is one of 4 different videos that were created by NASA this summer. And in this case, we're going to watch about half of this. It's going to be a teaser. She is going to tell us how NASA satellites help bring chips and dip to your table. So let's sit back and
we use satellite data to track. Hello, my name is Jocelyn Argueta, and this is Snack Time with NASA. Today we're making a big favorite in my house, chips and dip. We are NASA though, so this isn't going to be your run-of-the-mill dip. This will be a 7-layer cropland dip. Stick with me here. Did you know that NASA plays a big part in the food you eat? We use data from space to monitor agriculture and track food security. So coincidentally, we have some of the crops that we keep an eye on. Get it now? 7-layer cropland dip. So we can send a rover to Mars, but now the question is, can we make a tasty dip? But before we get started, I want to welcome Dr. Evil Becker, chef, who's here to tell us all about NASA's connection to the food we eat. Hi, Evil. How are you doing today?
Hi, Jocelyn. Great. How are you?
Awesome. It's great to have you. So first things first, are you a fan of chips and dip?
I love chips and dip. Yes.
Oh, good to hear. So as the director of NASA's Agriculture and Food Security Program, can you tell us a little bit about why NASA studies agriculture in the first place when we're known more for space exploration than cooking?
As we all know, our planet Earth is also a planet, and so NASA has satellites that are pointing out into space, but it also has a lot of Earth observing satellites pointing here down at Earth. And of course, that's really critical because we live here, and that's important for us to track and understand how we're changing our planet, how our planet is responding, and in particular, tracking agriculture, which is what we're concerned with here. Food security and agriculture are one of the biggest challenges we face in this century. And NASA's satellite data, since actually going back to early days of satellite monitoring, there has always been a large focus on agriculture. Agriculture covers a huge part of our land system. And what that does is that helps us to get an accurate and a timely understanding of potential shortfalls or surplus of crops and food production around the world.
So it sounds like everything is connected, much like different ingredients in a larger dish. And I've just laid down the first layer here of our dip, which are refried black beans. And sounds like Earth observations work in a similar way where things connect together. So how do these observations help us better understand food security and food production, especially in the face of climate change?
As we said, food security is one of the most important and critical challenges that we face. And so therefore, having information about where food is being grown, how much of it is being grown, how it's changing over time, how it responds to different climatic factors, to extreme weather events, which of course, as you've said, under climate change and a warming climate, we're seeing more and more erratic weather impacting our food production. And so we have various satellites going up above and turning around us all the time that are helping to monitor different aspects of the agriculture, of our agricultural system. And whether it is for helping us to distinguish where, for example, corn is being grown around the world, how it's developing, how it compares this year versus last year, for example, in the Corn Belt in the United States. And so being able to provide us that information in a timely manner on a global scale is really critical for understanding and making decisions relevant both for food security and for sustainability.
And I'm going to stop that there. If that tastes like more RRR to you, it is easily available to be seen. And there's a lot of other ones. Well, not a lot of, I'm sorry. There are 4 other cooking show episodes that we created that relate to NASA at your table. So I hope you will take a look at them. Let me move past that. All righty. So I did want to get a little bit into climate change because that is such a timely topic right now and is extremely complicated, kind of like the onion I was talking about earlier. Oh gosh, I love all these cooking. I didn't even mean that, but all these kind of cooking analogies. So when it comes to climate change, there is so much going on and it can be very complicated to understand. So that is one of the reasons why we're taking NASA satellite technology, and we're working closely with a lot of other countries to be able to get a feel for how are various Earth systems responding to these changes? What are the changes? And how can we both adapt to and then also mitigate some of these potential climate changes that are going to have a huge impact and already perhaps are having a huge impact on the food we have available to us and the drink we have available. So the last video I'm going to share with you, and then I'm going to step back and take questions, is one that we just created that focuses on how do we take data and put it together into climate modeling to help us better understand how to make these predictions for the future and how to then make decisions based on these models. So let me go ahead and play that for you.
The reason that we as humans care about climate change is that it affects not just the temperature, but a whole bunch of other things that we care about. It affects soil moisture, which in turn affects our ability to grow the things that we eat. It affects cloud cover. It affects rainfall patterns. It increases drought risk in some regions and decreases it in other regions.
Understanding our changing climate on a planet with incredibly complex and interconnected systems is a massive scientific undertaking. And climate scientists like Kate Marvel are using the data collected by satellites from around the world to improve the power of climate models. If we want to make better decisions about where we live, understand the changing impacts of hurricanes, or improve predictions of fire seasons, we need evolving climate models.
We don't have any observations from the year 2050, from the year 2100, but we can use our best knowledge of physics and chemistry and how the Earth system works in order to look at the impact of different emissions trajectories, different policy scenarios.
Climate models provide a view into our future, from our globe to our own communities.
As models advance, as they're tasked with predicting the nature of the weather and the clouds over smaller and smaller scales, they're being asked tougher questions like, well, What kind of clouds are happening over those small scales, and how often? And how heavily are they raining?
We expect roughly on really, really large scales, climate change is making wet regions wetter and dry regions drier. But at the same time, it's shifting the circulation of the atmosphere. So the locations on a very, very large scale of those wet and dry regions are changing.
Climate models are composed of lots of different calculations on the different behaviors of our atmosphere, our land, and our oceans. To accurately represent the natural world, they need massive amounts of satellite data over decades from NASA's Earth observation fleet and its partners around the world. Satellites like the Global Precipitation Measurement mission provide valuable rainfall data on daily to seasonal timescales for the past 20 years. And it's that information, along with a suite of other data, that go into climate model development.
Currently, GPM microimager radiance data are used to generate initial states of NASA climate models and to guide climate model solutions to be close to real states by applying data assimilation techniques.
Data assimilation is the process of combining many different sources of Earth observations into models to improve how we represent the Earth system.
Assimilating GPM microwave imager data improved intensity and locations of storms and precipitation calculated by the climate models.
And once a climate model is developed, it's tested over and over because, well,
all models are wrong, but some models are useful. So they're always going to be incomplete. They're always going to be a not exact representation of the real world. But we want to make sure that they are capturing important aspects of the Earth so that we can treat them as credible going forward.
Typically what happens is when you modify one part of the climate model, other parts accidentally change. It's kind of like the whack-a-mole game. By hitting it down, we're improving it, we're killing the error, we're decreasing the problem existing in the model, but another area pops up.
And that is why NASA observations of the Earth from space, the air, and the ground are critical to understanding how our Earth system works. Observations help improve the modeling for our future here on Earth with new capabilities to expand our knowledge.
NASA is launching satellites and coordinating missions like GPM, giving us that long-term, really accurate satellite record of what's been going on, not just of the temperature rising, but of various aspects of the climate changing. So precipitation and cloud cover and soil moisture and a whole bunch of different climate variables that people care about.
Continuing key observations of the Earth is really important to see how our atmosphere, land, and oceans are changing over time. A long-term record combined with cutting-edge observations from the new NASA Earth System Observatory will continue to push boundaries to better understand our ever-changing Earth.
So when we were talking about what is the future as we look ahead for, satellite missions and, not really even just for satellite missions, but as we look at how are we going to use science, technology, engineering, mathematics, and of course, reading and art and writing, and all of these things are an absolute essential part of the whole. I feel like even though we have some wicked questions to answer and some really challenging ways to forge ahead, that we have an awful lot of reason for optimism. We have just this amazing generation who's coming before us. I recently substituted in a classroom for autistic preschoolers, and those little guys, happen to be guys, were using a Promethean board and knew, how to manipulate technology. I look at a 1.5-year-old granddaughter who knows how to take my cell phone and scroll through pictures. We have so much ability, and sure, we have a lot of problems, a lot of things that we're going to need to figure out. But I have a lot of optimism. Even after having been a teacher for 30 years and being over 6 generations old, I kind of can look back and look at the ways in which we're able to come together, work together, and figure out how to solve wicked problems. So with that, I'm going to see if we have any more questions.
We do have one more question here, Dorian. Just if there's, can you do any recommendations or referrals to help connect schools if they want to bring in some kind of like how can programs kind of take advantage of these kinds of programs for their student body? And I through the NASA at My Library program, I am aware of the Solar System Ambassadors, and I know that that's national, and those volunteers are all trained by NASA before they go out into their communities, but I don't know whether that's the ideal recommendation or if you can pass on any other suggestions for school involvement with programs like this.
No, that's an excellent question. I'll throw out a couple of things. So NASA sponsors a program that is free called the Globe, GLOBE program. That is available not just to schools and teachers and scientists, but now using smartphone technology, because you all are walking around with these data collectors all the time. It is available to citizen scientists everywhere. So the GLOBE program, the free app, I would suggest downloading and using on a regular basis. And that way you're going to be contributing to NASA science and to scientists all around the world that are interested in collecting data from the ground and comparing and contrasting and integrating that with data being collected by satellites and helping us to better understand and then, of course, solve some things here on our planet Earth. So the GLOBE program is a great way to get involved. Solar System Ambassadors, Museum Alliance, NASA at Your Library, those are all wonderful, essential programs that are a great way to bring people who are volunteers in your neighborhood, in your community, to be able to interact with you. Those are two suggestions I would have. NASA also has a speaker series where they will try to match up a speaker, with your classroom. I am also happy to, especially virtually, come into people's classrooms. And I know a lot of people who operate like I do. They support a NASA Earth observing satellite mission, and they're always wanting to find ways to share just the amazing resources we have and the science and technology being done with our community. So very often, especially virtually, we're very happy to come into your classroom. So those are a couple of suggestions I would have.
Thank you.
You are most welcome. And I guess before we finish up, let me see if I can, oops, I thought I could click on that. I was going to go and take a look at, and I will just click on it. I guess I can't. Maybe, the one fly in the ointment, I did not make this a slide that I can go to. Perhaps you could put the link for the Padlet in the chat box that I have access to, and I can take my computer to that. Or you could share your screen. I just thought we could take a look at and see if anybody had added information to our Padlet, any more that perhaps they learned or questions that they might continue to have about NASA and agriculture. Oh, good. Thank you so much. Okay, let me go to that and switch over here to that screen. Marvelous. And we'll take a look and see if we got anything on that. Trying to play Wizard of Oz here and click through those. Let me, there we go. And I'm not seeing anything come up there, but that really is neither here nor there when it comes to what we're working on here, because I can take a look at that a little bit later and see if anybody added anything. So I want to say thank you so much for joining us. Feel free to reach out to me if you're looking for more resources, if I can serve as a resource to you, and should you have any more questions about this topic. And I will, of course, remain on. Yeah.
I just want to say, I think I can bring this onto the screen if you wanted to review it.
You are brilliant. Oh, fantastic. Thank you so much. So good. It looks like we did get some people responding to us there, and that is wonderful. It is a little bit small on my screen. Let me see if I can make it a little bit bigger. So good, to create better water systems. And indeed, that is absolutely right. Less rain, less food can be true, but that's a part of what it is that we need to do as a global society to be able to figure out how to use things like hydroponics, how to use vertical growing systems, how to reuse freshwater resources. So a lot of pretty amazing things that we're starting to be able to do with technology. Most certainly, we need cleaner water. Thank you for whoever raised that. I work with the Montgomery County Public Schools outdoor environmental education programs 1 day a week. And on Monday, I brought about 80 sixth graders through our stream study. And so we go into the stream, we get wet, we find different macroinvertebrates, and that helps us to better understand the quality of the water that's in our streams. So absolutely, being sure that we have clean water is very important. Understanding flooding and droughts, the impact that they have. So good. I can see that we've really got some great ideas coming in here with this Padlet. And thank you for making this a little more interactive. Sometimes without having actual people in front of me, I kind of feel like I'm just talking into space. And of course, that's part of my job, right? But it's nice to sometimes get a little bit of feedback and interaction there. So thank you very much for doing that.
You bet. And Phil, I wanted to ask if you wanted to say a few more words about the festival.
Sure. Thank you, Dorothy. First off, we just put on the screen a QR code. We'd love to have your feedback on this program. So if you can hold your camera up and take a picture of the QR code, it'll take you to our attendee survey. And I also wanted to let you know that throughout the festival, we have 2 more great NASA programs. Next Tuesday, November 2nd at 3:30, we have a program on laser communication. Dave Israel, the principal investigator for the laser communication relay demonstration, will be talking about NASA's optical communication technologies and how they're using lasers to communicate, something we might not think about a lot. And then on the 9th, we are having space communication and navigation with astronaut Dan Janney. That will be on the 9th at 4 o'clock. And he'll be discussing how they navigate satellites and crafts without terrestrial points of reference as normally is done with navigation. And he will be talking about his career as an astronaut and his trips to the International Space Station. So you can find these and all Maryland STEM Festival events on our website, which is very straightforward, www.marylandstemfestival.org. I want to thank again Dorian for the great presentation, as well as our partners, and Dorothy for running the show, and Carrie for joining us today. And again, we appreciate your support of the Maryland STEM Festival and look forward to seeing you at events through November 14th. And I'll turn it back to Dorothy for the final word.
Thank you, Phil, and thank you, Dorian, for a marvelous presentation. And Carrie, I'm so glad you were able to join us again this evening. Dorian, we're going to have you back. We've had you 2 weeks in a row, and it's been marvelous.
Thank you. My pleasure.
And thanks to our audience for joining us this evening, and have a good evening.
Thank you.
Bye-bye. Have a great